it down.
Oh, so then there's no more pound sign. That breaks it. Okay. So.
Yes, Carl.
Is it possible to set V to be part of A P to the P and part of B to the P? Like, is it possible?
V both here?
Yeah, like.
Yeah, that's possible. I think Michael covers it. In that case, if you pump, then the first string is different from the second string. Yeah, Michael explained using one example, right?
Yeah.
When V and Y is only one symbol, A or B. But make sure you write in general case when you write exams or quiz.
Okay. Well, no, I showed two examples because I showed the example where V is A to the P and then Y is B to the P, and then it breaks because this side is not equal to this side. But I also showed if this whole thing is V X Y, because if you put
this whole thing cannot be Vxy because Vxy is less than P.
Okay, yeah, okay. Then partial sum of it.
Right, right.
But yeah.
Yeah, well, the idea is in general correct, but make sure you don't write something like V equals A, Y equals B.
Okay.
Because if you write it that way, I would say that you only show one case where V is A and Y is B, but there could be V is 2A and Y is 2B, 3Bs.
So say V equal to AI? Or?
Yeah, you have to say something like that. This is a very common mistake in the quiz I graded. Everyone follows. Well, at least you know how to do such reasonings, right? Okay, now the third problem is actually a very challenging problem. It's not related to pumping lemma, but Dr. Lee thought that is necessary to talk about in the recitation session. That's I put it there. How do you show that one language is context-free?
You can write a context-free kernel for it, PDA.
There are two ways. One is write context-free and one is write PDA. Which way is easier for this question?
Context-free. PDA, I don't know.
Really?
Yes, we can try and the first person to come up with one.
Actually, for PDA, it's very easy to write something like this, reverse, because it's a stack. But this, how do you make sure that the two strings are the same? You have to reverse the stack, right?
Isn't it the same as doing 0n, 1n?
0, 1. No, they're different because in 0 and 1n you just need to keep track of the number of zeros. But here you have to keep track of exact character.
Oh, the character.
Read in the opposite symbol from what's on top of the stack. Pop it each time.
So you try to flip the stack.
Yeah. Like you just said.
How?
That would work, right?
Then you need two stacks to flip it, right? Yeah, think about that problem. Somebody suggested that context-free is easier. That somebody is not only Matt, but Dr. Lee.
That's beautiful.
Can I remove this panel? Yes. I give you 5 more minutes to think about the idea, and then we talk about it. Then you can start writing the grammar.
Oh, so
Well, if you have an idea how to write the grammar, you can.
or we could do a PDA, right?
Yeah, you can do PDA too. Personally, I don't know how to do it. If you can show me, that would be very great. Okay, any idea? How do you check two strings are not equal? Car.
This is just an idea. Is it possible to choose a string that would encompass like every possible value for x, y in the language, and then if you prove that for all cases that is that doesn't violate the pumping lemma, would that work as a proof?
No, you cannot use pumping lemma to prove that a language is context-free or regular. That's also a very common mistake. You show one string and you show that the pumping lemma does not work, and you claim that the language is regular. No. Okay, what's the idea? We show two strings are not the same. If there is at least one position that's different. Do you agree?
Yeah.
Well, how about strings of different lengths? We can say that this position is some epsilon character. Right? So if you write a grammar saying that guarantees that there's at least one position that's different, then you basically generate different strings.
So this should also accept strings of arbitrary length, so
Right.
A could be really long, B could be empty.
That's true, but hint 2. Strings of different lengths can be considered as a string of as two strings of the same length, but has the same number of positions. Like just filling the positions with epsilon. Right?
But there's no restriction on length.
There's no restriction on length. You can say these are two strings of the same number of positions. And as long as you guarantee at least one position is different, you do it. Jeff. You always do the difficult problem.
What's that?
Okay.
On this side, this one has a 0, on this side it has a 1, and then you just reverse it over here. And then it could be, the R's could just be anything.
How do you guarantee that the two different R's has the same length?
I don't know.
Because, for example, from here, I can generate 0, 1. And from
You can do
here,
something there.
0, 1 can be generated
Okay,
too.
I got shot down.
Okay. Any clue? Now the problem breaks down to how do you identify the same position of two different strings. Context-free grammar can always identify the middle symbol of a string, right? Actually, arbitrary position can be identified as the middle symbol of some strings. How does it work? For example, this position, we can add 3 epsilon. That make it the middle symbol.
More complicated than it needs to be. I think that'll do it. So basically, you can recurse on S, and you just keep replacing S. So you have some long string, like you would just have S, and then you would replace it with 1 S 0, and you would just keep replacing this S with 1 S. one S, and until you got to that. Until you got to the last.
From here, do you require that for the string that's adjacent to the pump symbol, they must be different?
So I put these in so that we could, at the end, as long as you've pumped with S, not pumped, I guess as long as you've recursed on S,
Okay.
even if you built only zeros and then you replace the final S with one of these two, then you have a different number of zeros on either side.
Oh.
So that you have two different kind of parts of S. You can recurse on the S variable and keep replacing it.
Let me.
0 pound 1, where's
0 pound 1. How would do you want me to like write a parse tree for that? Or?
Yes.
Oh, okay. I see what you're saying. Because I don't have that one.
Basically, you require for the two symbols that's next to pump, they must be different.
Yeah. Yeah. Or could I do 0, S, 1, S? No, I don't have another S. Yeah, I could do that. I could do that. I can do this one. I can do S goes to 0, S, 1, and that S becomes 0, S, and that S
Oh,
becomes
okay.
pound 0.
Okay.
This is ugly as sin. though.
Then you can also generate this.
Oh, because I have these.
Right.
Yeah.
So can you just get rid of those? Because you don't need those. Do you?
He kind of does.
Yeah, because then without these two, you can't generate strings. Yeah, there's something wrong there.
Okay, we're running out of time. Let me just tell you my solution. Well, this two says in the middle of the string, they must be different. And for the rest of the symbols, we don't care. For example, this one. This two string. I'll consider this is A, this is B, and in the middle they are different, and for the rest we don't care, they can be anything.
What if the middle ones are the same and maybe the last one is?
Oh, the last one can be considered as the middle of a different string, right? For example, well, this is not a middle, right? Let's answer Tanya's question. We can make any position of the string to be a middle string. Make sense? Everyone? Because for context-free grammar, it's very easy to control the middle symbol of the string. Yeah, just find out a way to turn the middle symbol to arbitrary position. Yeah, that's all for today. Thank you.
Could you show us the solution for the fourth one?
To which one? For the full one? Oh, it's a very complex proof.